Okay, we're going to look at problem 449. This is actually not a hard problem, but quite frankly, it's the solutions are not available in the solutions manual, so I wanted to spend time on this. The reason I actually assigned this is a little bit of history on there, is I put this on a test one time, and people really struggled, and I was surprised that they struggled, but it's because of this connection right here. They hadn't had any problems doing that, and so we're going to do this. So what you have here is you have this thing, and you have a wire here that has a tension of 1300 newtons, and we're supposed to determine the reaction at the fixed support C of the frame shown. Okay, so let's draw this free body diagram. I'm going to come over here. We're going to have this free body diagram. It's going to come down here. And really, the only thing that's going to be kind of new here is how to do this. So here we got 750 coming down this way. You have 450 coming over here. We're going to cut through this, and so you have 1300 coming this way, right? So our free body diagram, what are we doing? We're kind of going around like this. We're cutting through right there, and we're cutting through that, right? So we know that tension is there. Now here, let's look at this. It's a fixed support. So what is that fixed support doing? Well, it's causing a reaction in that direction. We'll call that CY. There's one in this direction, right? CX. And the difference is, and what's unique about this problem that we haven't done a lot of problems with, is there's a moment. This thing is resisting the urge to rotate, and we're going to call that the moment at C, right? Because if you look at this here, I'm going to erase my marks so we can see it a little better. If you look here, this type of reaction, I mean, just in the real world, we all know that it's gonna, it's not going to come up or down, it's not going to go left or right, but it's going to resist this whole thing from tipping over, right? And so here are the three unknowns that you can get from here. So then it's just a pretty straightforward problem. So some of the moments, some of the forces, right? So where do we pick the moments? Well, quite frankly, to me, what makes the most sense is picking here at C, because you get rid of 1, 2 unknowns. So let's say the sum of the moments at C is equal to 0. So what do we have there? Well, you have 750 times 0.5, right? That's going to make it rotate in that direction. It's going to go whoosh, oops, like that. And we're going to add plus 450 times 0.4. That's also going to make it rotate in that direction. Now we're going to have this force. I'm going to account for this force as this portion of it and this portion of it, right? I'm going to call, just for clarification, I'm going to call this 1300 in the y direction and this the 1300 in the x direction. So it's actually not a value of 1300, and we'll figure that out in the next step, but just for clarification. So those are going to be in the opposite direction, right? So minus 1300 y, the y portion of it, times its distance, which is 0.15, minus 1300 in the x direction times its distance, which is 0.6. Okay, and then there's one more thing, and that is simply this moment. And since I have defined this direction as positive, it needs to be plus the moment at C is equal to 0. And that's it. So all these numbers, now let's figure out the x and y component of this. So this triangle over here is, boom, I'm looking at this triangle right here, right? Actually, I guess I could just draw right here. So this is 600, this is 250, so this works out to be 650 here, okay? So the y component, the 1300 in the y is 1300 times 600 over 650, and the x is going to be 1300 times 250 over 650. I'm going to get rid of the extra zeros while I'm doing this math. Okay, so therefore, coming back to this equation here, we're going to solve this for MC. So MC is equal to 1300 times 60 over 65, all that times 0.15, plus 1300 times 25 over 65 times 0.6, and then it's going to be minus 750 times 0.5 minus 450 times 0.4. So you get the moment at C is 75. Well, actually, it's minus 75 Newton meters. Or in other words, it is equal to 75 Newton meters in that direction. Okay, so that's the moment at C, and then the rest of the stuff is pretty straightforward. Sum of the forces in X equals 0. So what do you have in X? Well, you only have this force and this force and this force, right? So the way I drew it, we're going to have Cx plus 1300, the X portion of it, which is 25 over 65, right? That's going to equal 450. So, whoa, sorry. So Cx is equal to minus 50, right? So in other words, we drew it in the wrong direction, but that's fine. So there's our Cx. And last is the sum of the forces in y equals 0. And you're going to do the same thing here. Our y forces are Cy, this 750, and the y portion of that. So you're going to get Cy, stop that, equals 750 plus 1300 times 60 over 65. So Cy ends up being 1950 newtons. And that's that. So again, the main takeaway, the reason I'll assign this problem is that when you cut through a fixed thing here, you have your x and y, but you also have a moment. And that's what's unique to this problem. But it's not hard. It just makes it a little bit different than the other problems that we've done.